Welcome to this GCSE question. It concerns an isosceles triangle with a line joining one of the sides at right angles. Okay, as you can see. Now, before I start to solve this, which I'm going to do in two completely different ways, okay, before I start that, I'm going to notice that the diagram given isn't really to scale. In fact, these two lines of 10 appear to be longer than the line of 12 here. So to make it easier to understand the problem, I've decided to redraw it more to scale, okay, and I've done that under here. There it is. Okay, so you can see that the line of length 12 is a bit longer than the two lines of 10, and this line of 10 here I've split into y and 10 minus y, which add together to give 10. It also is the case that the line x joining at right angles here is actually joining around here rather than up here, as shown on the first diagram. So this is a more realistic picture of what's going on. Okay, so I'm going to now use Pythagoras' theorem to start with to solve the problem based on two right-angled triangles. Okay, so I'm going to start by looking at triangle ABD. So I'm going to put here in triangle ABD, okay, I can say that by Pythagoras x squared plus y squared equals 12 squared, which is 144. Okay, I'm going to call that equation 1. Okay, and then I'm going to look at the triangle on the right-hand side, which is triangle BCD. Okay, and I'm going to note that that also has one of the short sides as x squared. The other one is 10 minus y all squared. Okay, and if I add those two squares together, I get the square of its hypotenuse, which is 110 squared. Okay, now I'm going to expand out that bracket, x squared plus, now this is 10 minus y times itself, okay, like that, and that equals 100. If I now carry out that multiplication, I'm using FOIL, first outer inner last. 10 times 10 is 100. Okay, minus 10y and minus 10y gives me minus 20y, and minus y times minus y gives me plus y squared, and that equals 100. Okay, now I can notice that both sides have 100 on them, so I can just subtract 100 from both sides, and I'm left with x squared minus 20y plus y squared equals 0. Okay, and one final thing I'm going to do is I'm going to change it slightly so that I move the minus 20y and the y squared onto the other side, so I'm writing x squared in terms of y. All right, so I need to add 20y and to the 0 and subtract y squared. Okay, so that's led me to equation 2. And what I'm going to do now is I'm going to use that expression there for x squared, and put it in place of the x squared there. So my first equation becomes entirely in terms of y. So I'm going to sub for x squared, sub equation 2 into equation 1. Okay? All right, so it's going to look like this. So instead of writing x squared at the front here, I'm going to write 20y minus y squared. Okay, 20y minus y squared. And then I've got plus y squared equals 144, you see. Now, you'll notice that the y squared minus and plus y squared cancel out. So I'm left therefore with 20y is equal to 144. Okay, therefore y must be 144 over 20. Okay, and 144 over 20 is equal to 72 over 10, which is 7.2. All right, and if you look at y on the diagram I've drawn here, it looks about right. Okay, compared with the 12 and the 10, it's a bit less than the 10, 7.2. All right. Now, if y is 7.2, I can then substitute 7.2 into this equation for y to find out what x is. Okay, so I'm going back to equation, so I'm subbing 7.2, I'm sub y equals 7.2 into equation 1. Okay, so that gives me that x squared plus 7.2 squared equals 144. Okay, that gives me that x therefore, if I take away 7.2 squared from both sides and square root everything, I get that x equals the square root of 144 minus 7.2 squared. That's just rearranging the equation immediately above it. Okay, 7.2 squared. And if you put that onto a calculator, that will give you exactly 9.6. Okay, and indeed that is the right answer. Now, just before I move on to the other method, just have a look at that 9.6 and look at the line that we've got here. Now, I can see that x is a bit shorter than 10. Okay, 10 is the hypotenuse, the longest side of the triangle. That's a bit shorter. So I was expecting something close to 10, but certainly not more than 10. And that's what I've got here. Okay, so it's a good way of kind of checking your answer. Look at your diagram, and provided it's roughly to scale, it should give you a good idea. Okay, now we move on to the other method, quite different to that. So I'm just partitioning that off there. Okay, and this is how it works. I'm going to go back over here and I'm going to now consider the area of the large triangle, the whole thing, in two different ways. So area, first of all, of triangle, now this time we're talking about ACD, that's the whole thing, with, now first of all we're going to look at it with one of the lines as a base and the other as a height. Okay, so I'm going to look at it with AC as base, okay, because we talk about the base and the height of a triangle. Okay, and I'll put base in inverted commas because it's not actually sitting on that base, but we often talk about the area of a triangle being half base times height. So imagine this triangle was tipped over. This is the base here between A and C, and the height is the perpendicular height, which is x, you see. So the area of the whole of that triangle is a half of base, okay, times height. Well, we know that the base is 10 because it's 10 minus y plus y, which is 10, all right? So the area of triangle with AC as base is half base times height, okay? So it's a half of 10 times the height, which is x. Well, that's clearly 5x, okay? So the area of that big triangle is 5x, okay? Now I'm going to look at the area of the same triangle, okay, but with a different base and a different height. Okay, so area of triangle ACD with not AC as base, but with AD as base. Okay, AD as base. Now, look what happens now. Okay, the base is 12. Now, the height, if we do it this way, is going to be this green line I'm going to add here. Okay, about here. Okay, now that green line comes from a right angled triangle, because there's a little right angle in here. Yes, this is going to be exactly half of 12 because it's an isosceles triangle, so this is going to be 6. That's 10. Okay, so if I call this point here E, because I've used A, B, C and D so far, so EC, so I'm just going to write first of all that maybe if I just do that here, okay, down here, EC is going to be the square root of, okay, 10 squared minus 6 squared, okay, by Pythagoras, okay, and 10 squared minus 6 squared is 64, okay, it's 100 minus 36, and therefore EC is equal to the root of 64, which is 8. Okay, so I'm using that information there. I'll just done that on the side there, but that piece of information in there, okay, that I've just worked out, I'm going to use to find the area of the triangle using that as the height, okay, and 12 as the base. So in this case, the area equals a half of base, which is now 12. Okay, there's the base times the height, which is 8. Okay, and if you take half of 12 times 8, that's a half of 96, which is 48. Okay, now it's quite easy because we've got two expressions for the area of the same triangle. One is 5x, the other is 48. So therefore, 5x must equal 48. Okay, and if 5x equals 48, then x must equal 48 over 5. Okay, and 48 over 5 is 9.6. All right, so that method is quite quick and simple once you've decided or spotted what you could do. Okay, but that is the answer that we got last time. It is the correct answer. So there we have two quite different methods for solving the same problem. Okay.